region should like that because we can know that x is larger than 1 over y, which is this line, and smaller than y. So we can have two functions that when x is 1 over y, we can get this line, and when y is x, we can get this line. And because x is between them, so the area should be the yellow area. And also the intersection of these two lines is that when x is 1 and y is 1, they have the intersection. So when y is larger than 1, which means the area that beyond this point. When this joint density function is valid, we need to do the integration. First, x is from 1 over y to y, which is this area, and then the y should from 1 to infinity. And we can write the function like this form. And then first we need to try this function. And because we can see the 1 over a multiplied y squared as a constant, we just need to do the integration for the 1 over x, which is the ln x. And then the result should be um, 1 over a multiplied y squared and multiply the ln y minus ln 1 over y, which is ln y minus ln y add ln y, which is 2 ln y. So the result should be like that. And then we need to do the second integration, that is from 1 to infinity. So first we need to replace the y with e to the power of alpha so that we can do the integration. And after that we replace y, we can get this item using the replacement. And then when we do this calculation, we can know the result should be like this form. And we can know that the integration of this item should be the 1 minus alpha multiply e to the power of negative alpha. And then after the calculation, we can know that 2 over a is 1, so a is 2. The density function for x is when x is larger than 0 and smaller than x, we need to do the integration, that is from the 1 over x to infinity. So we can consider the 1 over 2x as a constant, and we just need to calculate this item, that is 1 over y squared. And it should be the 1 over 1. And after the calculation, we can note that the result should be a constant, that is 1 over 2. When x is larger than 1, which is this part, we will note that the integration is from x to the infinity, and also because these two are in the same form, so we can just use this result and change the range. So the result after calculation, we will know the result is 1 over 2 multiply x squared. And the figure should like that. And then when we try to solve the density function for y, we can just easily using the range from 1 over y to y, and we do the integration, because this form is just like the problem 2. So we can get the result that, because this is we can see 1 over 2y squared as a constant, and we just need to consider the 1 over x, the integration of 1 over x. So the result should be line x, and the range is y is 1 over y to y. So the result should be 1 over 2 y squared multiply 2 L and y. So the result is we can eliminate 2, so the result is 1 over L and y over 1 y squared, and y is larger than 1. And then we need to verify the density, these two density function. So we can do the integration, like first for the density function for y, it should from 1 to infinity. And because this integration is just like the problem 1, so we can just use the same formula that is in the same form as the problem 2, and the result would be 1, so it is valid. For the density function y, there is two parts. One part is from 0 to 1. Because we can easily know that the area from 0 to 1 is the half, and we just need to calculate the second part. So for the second part, it is the integration from 1 to infinity, and the function is 1 over 2x squared. And the integration is, and the result should in this form, and the result is, the value is 1 over 2. So this area is 1 over 2, and the remaining area is 1 over 2. So the whole area is 1, so it is valid.